Section 1.1 is horizontal and vertical translations. So what we're going to start with is nothing overly new to what you've done before. It's just a bit of a review of what that HK, or in the case of Pre-Calc 20, the PQ function did when we were applying it to different equations and functions. So we're just going to go through a few examples here. You can do this with your graphing calculator just to try it out and then compare it to what I have, or you can just follow along with me here. I'm just going to pause for a sec so I can bring up my calendar or calculator. Okay, so the first thing we're looking at is the absolute value function, and it says if you use a graphing calculator, first thing you always want to do is clear all your functions. So whether you just do clear, or when you're in the y equals mode, do y equal to, and then make sure you're cleared so you don't have any other equations in there. So y is equal to absolute value of x. Remember last day I showed you absolute value, you need to go into your math function and then over to numbers. It's going to look a little bit different in the TI-83 compared to the TI-84, but the only difference is going to be that you have the 84 puts the actual vertical lines, whereas the 83s and 82s will just put brackets there, but it'll do the same thing. So I want absolute value, and now I enter in there, so I just need the x. So if I hit graph, I get a graph that looks like that. So let's go back into y equals, and let's put in x minus 2. And you have to use minus, not negative, because there's a difference between an operation and a sign. So x minus 2, if I graph that, what's happened? So my graph has moved over to the right 2. If I change that equation into y is equal to x plus 1, and then graph it, you can see my graph has moved 1 to the left. Okay, so now let's try it for y is equal to x squared. So x squared, if I graph it, I'll get my parabola going through the origin. If I change that to y is equal to x plus 3 squared, and I'm going to do that on the next one here just so that we can see more of a comparison. So y is equal to, in bracket, and then put your x plus 3 all squared. If I graph it, it's moved it over 3 to the left. And if I do x minus 1 all squared, oops, I must have, well, I missed my first bracket. So I want to insert the bracket. No, not there though. I'm just going to clear it and do it again. Okay, so bracket x minus 1 squared. So there's x squared, x plus 3, and x minus 1, you can see, has moved it 1 to the right. So what's happening then is it's going the opposite direction. If it's a positive, it's going to the left. If it's a negative, it's going to the right. None of that should be new to you, because that is what we spent a lot of time doing in Pre-Calc 20 with our function unit, quadratic function unit. So the next part says, give the new equation for each translation on the square root function. Y is equal to square root of x. So when we do that, if it's y is equal to, 4 units right, based on what we saw there, if we want it to go to the right, we'll have to put in a negative sign. And because it is the x that's moving, we have to make sure that that is inside or underneath the square root sign, inside the bracket or underneath the square root sign. So if it's 3 units to the left, we're going to do y is equal to square root of x plus 3. So if we want to compare what happens to the equation y is equal to fx to y is equal to, or y minus x is equal to fx, so basically what we're doing is we're replacing the y with a y minus k. And this is the same as saying y is equal to fx plus k. But they've taken and put this on this side just to show you that that k value affects the y coordinate. So if I look at y is equal to x cubed, I'm just going to clear all of these quick. Okay, so y is equal to x cubed. So to do x cubed, quickest way is just to use your caret function. You can go into the math and put in a cubed. So if I do that graph, if you remember, it gives you that curve going through the origin. So if I change that to y minus 1 is equal to x cubed, and it says, note, you have to solve for y before entering this into the function. So what you have to do is, I can't put into my y equals here y minus 1. I can't go to the left there and try to stick in a minus 1. So I have to add 1 and move that over to the other side. So what I have is y is equal to x cubed plus 1. So y is equal to x cubed, and you have to move over, otherwise it's going to do x to the power of 3 plus 1. Oops, I forgot my plus sign. Plus 1. So you can see my graph has gone up. If I do y plus 2 is equal to x cubed, this is going to become y is equal to x cubed minus 2. So x cubed, oops, minus, not negative 2. Graph it. You can see it's moved down 2. Okay, so let's see what happens then when we do this to a square root function. So going back into here, clear. So if I want to do a square root function, I need to do the second. So y is equal to, and it's a second there, so square root x, graph it. It gives you that half of a sideways parabola. So y plus 3 is equal to square root of x. Again, you're going to have to move that over, so it's going to be y is equal to square root x minus 3, and it's important to remember that this is outside the bracket, not inside. It's affecting the y coordinate, not the x. So that's why it's not underneath that square root sign. So y is equal to, and again, you need to move over. Hit your space or your right arrow to move it over, minus 3. So you can see it is now moved your origin down 3. Y minus 2 is equal to square root x. So again, we're going to have to move that over. It'll be square root x plus 2. Okay, so square root, oops. Oops, okay. So square root x right arrow, so you move it out of there, plus 2. I didn't put my x in. Nice. So you can see that it has moved it up 2. So what happens to the function? Well, if you are adding 3, it's going to move it up. And if you are subtracting, it's going to move it down. So it's affecting where the y is being placed. So it says, now give the new equation of the translation of the quadratic function y is equal to x squared. So if I'm starting with y is equal to x squared. If I'm moving it up 4, then it's a plus 4. If I'm moving it down 3, then it's subtract 3. So just some translation tools just to help you when you're working on these. When you replace x with x minus h, the graph is translated in which direction? So if h is greater than 0 or positive, then the graph moves to the right. Because what they're saying in here, and this is where some people get a little bit confused, you're replacing it into the x minus h, so that means that, say if I said it was a 2, then I would have x minus 2. So that means this moves to the right 2. Or the graph moves, I guess I should just put to the right. For my example there, it would be a 2. If h is less than 0, so then that means I'd be substituting in a negative number, so we'll say like negative 2, then I would have x minus negative 2, which is x plus 2. So then my graph moves to the left. When you replace y with y minus k, the graph is translated in which direction? So if k is greater than 0, then the graph will move up. So, yes. If I change this to y is equal to x plus k, then if k is greater than 0, it's going to go up. And if k is a negative value, then the graph is going to go down. Okay, so the next one says sketch the graph of the function y is equal to x minus 3 squared plus 1. Think, what is the base equation? So your base equation is y is equal to x squared. So y is equal to x squared means I go through the origin, I go up 1, up, or over 2, up 4, and then it'd be 3 and 9. So this would be my base equation, which in the assignment that you did the other day, they called the parent equation. So if I try to do this with the table of values for x minus 3 squared plus 1, if I substitute a negative 3, I have negative 3 minus 3 is 9. Is negative 6. Negative 6 squared. Did I do that right? Oh no, sorry. I should have done a table of values for your x squared. So if we just did x squared, it'd be negative 3 and 9, negative 2 and 4, negative 1 and 1, 0 and 0, 1, 1, 2, 4, 3, 9. So if we were to do a table of values for the y is equal to x minus 3 squared, you would notice that we would have some movement in there. And probably the easiest one to do is with the 0. So if I had substituted a 0, so this is for... If I had substituted a 0 into the y is equal to x minus 3 squared plus 1, at 0 here, I would have negative 3 squared is 9. Negative 3l squared is 9, plus 1 would be 10. So this would be at 0 and 10. If if I do it for, let's say, positive 3, I'll go down here. 3 minus 3 is 0. Plus 1 is 1. If I did it for 2, I'd have 2 minus 3 is negative 1. Negative 1 squared is 1, so plus 2, so 2 would be your answer. Oh, I have to sneeze. And we could continue going on. But if we think about this as the translations, I have a negative 3 inside there, so then that means my origin needs to shift over 3 to the right. So I need to move my x 3 right, and my y, because it's a plus 1, needs to go 1 up. So from here, this point here is going to move over 1, 2, 3 spots, and it's going to go up 1. So my new origin is going to be there. And then from there I can do my regular points, my over 1, up 1, over 1, up 1, over 2, up 4, over 2, up 4, and so on. So you can check a couple of points here. I went over 2, up 2. Well, that worked out to be one of my points. I went over 3 and up 1. That was one of my points. If I had continued my graph, those points would match up exactly. So you can do the translations without having to do the table of values by just doing your over or left or right and up or down. So this, pretend that went through there. That would be where that graph is at. So what is the domain of this new function? Of the new function, I could have chose any values. So domain is all real numbers. The range, because of this translation, I can't go less than that positive 1. So the range is going to be everything greater than equal to 1. What are the x and y intercepts? Well, if I look at the graph from what I have, I can see that it's never going to cross my x-axis here. So x-intercept doesn't exist. It's the empty set. The y-intercept, I haven't calculated it there, but I could by putting in y is equal, or x is equal to 0. Remember, to find the y-intercept, you let x equal to 0. Well, and I happen to have done that right here. So y-intercept, let x equals 0 and solve, so the y-intercept is at 10, or the point 0 and 10. So y is equal to the absolute value of x plus 1 minus 3. Think first, what is the base function, and then do your translations from there. So for the base function, that would be y is equal to absolute value of x. So if I start plugging in values, at negative 3 would be 3, negative 2 is 2, negative 1 is 1, 0, 0, 1, 1, 2, 2, 3, 3, and I could go on and on and on. So my base function is going to be a nice straight line going like that, and then one going, that's a bad one, but you get the idea. Okay, so if I look at my translation, I have a positive 1 inside, so that means I'm going to have to go left 3. I've got a negative 3, so I'm going to have to go, left 1. A negative 3, so I'm going to have to go down 3 for my translations. So if I was at 0, 0, now I'm going to have to go left 1 and down 3. So that's my new origin, or my new 0, 0. And then the other points that follow will follow in the same pattern. I'll go over 1, up 1, over 2, up 2, over 3, up 3, 4, 4, and so on. So then the other way it'll be the same. And again, I should have a nice straight line going through each of those coordinates, but you'll do better. So, and I can check from any of these points too. So take, for example, from this point here, using my translation, I should have gone to the left one and down 1, 2, 3. So you can see I could do a count, but if I did that for every single point, it's going to take you forever. But I could do any of the points that were on my original graph. If I did the translation of left 1, down 3, I would get my purple coordinates that I have there. So what is the domain and range for this graph? So the new function, I have shifted it, but my x values haven't changed. I can still use any x that I want. That should be purple. My y, though, now I've gone down as far as the 3, and now, or negative 3, and I'm using everything above. So my y is going to be everything greater than or equal to negative 3. The new x and y intercepts. So the x-intercept, it cut the graph here and here. So at negative 4, 0, and 2, 0. And my y-intercept now has shifted from 0, 0 down to 0, negative 2. So x-intercepts, we're at negative 4 and 0, and 2 and 0. Y-intercept is now at, whoops, 0, negative 2. Oops. So graph the function y is equal to 4 minus x minus 5 all squared. So what is the base of this equation? So the base of this equation is I need to take out the translation. So it's going to be, and this is where you might get confused because it looks like it's just a regular square root function. But if you remember in the review, I gave you the, well, it looked like this, x minus r, x squared minus r squared. That was for a semicircle. So this is a semicircle function. So my base equation would be y is equal to 4 minus x all squared. So my translation on this one is then that negative 5 here, which means I'm going to go right 5. So for my base equation, if it's 4 minus x squared, square root of 4 is 2, so then that means I would only be going 2 away from the origin for each one of these. So this would be the base. So now my translation, I'm going right to the right 5, so my origin, which was here, is now, or the middle of it, each one of these is going to shift over 5 spots. So if I take this point, I move it over 1, 2, 3, 4, 5. That's where this one has now translated to. This one up here is going to move 5, 1, 2, 3, 4, 5. And this one here will move 5, 1, 2, 3, 4, 5. So there's my translated function. Domain and range for this? Well, I don't go any lower than on my y. I don't go any lower than 0, and I don't go any higher than 5. So my range, sorry I did these backwards. And my domain, I've gone between 3 and 7. Okay, example 4. Given the function y is equal to fx on the left, sketch the graph of the new function y is equal to f of x minus 3 minus 2. So we need to take a look at, okay, what are my translations that are happening? So the first thing that I can see here, my h is equal to 3. So I'm going to go right 3. My k is equal to -2, so I'm going to go down 2. So every point from this graph here, that wherever it was on the original graph, is going to be translated 3 right and 2 down. So you pick your key points in here. So wherever the graph changes direction, or wherever it's crossing the x-axis or y-axis, you want to choose those points. And a start and a finish is a good idea. So I've got a few here that I need to translate. So in this one here, my first point was -7 and 4. And then I went to 3 and 0. Sorry, not 3. Oh, I guess I did do that one. Right, -3 and 0, not 3 and 0. I'm down here at -2 and -1, and across to 0 and -1. And then I went down to 2 and -3, and then back up to 5 and 0, and then finally I ended at 7 and 2. Okay, I probably didn't need to pick quite so many. I could have gotten away with not doing this one and this one, but it's not a bad idea to include them. So if I'm going right 3, my -7 then is going to be -7 plus 3, so that becomes -4. My y coordinate is being affected by a -2, so I go down 2. So it's going to go to 2. -3 and 0. So -3 plus 3 is 0. And 0 minus 2 is -2. -2 plus 3 is +1. -1 minus 2 is -3. 0 plus 3 is 3. And -1 minus 2, -3. 2 plus 3 is 5. -3 minus 2 is -5. 5 plus 3 is 8. 0 minus 2 is -2. And the last one is 7 plus 3 is 10. And 2 minus 2 is 0. So that's going to be where my new points are. So -4 and +2. 0 and -2. 1 and -3. 3 and -3. And then it's 5 and -5. 8 and -2, so I'm not going to be able to show you that one because it's transformed off the graph, but 8 and -2, 7, so be about right here. And then your 10 and 0 about right there. So my graph is now going to go like that. So the next example says, if the point 2, -3 is on the graph of the function y is equal to fx, determine the new coordinates of the translated image of this point on the function. So y is equal to the function of x plus 5 plus 1. So this plus 5 means I'm going left 5. So I'm going to subtract 5 from my whatever my x value was. This plus 1 means I'm going to go up 1. So then that means I'm going to add 1 to my y. So if my original was at 2, it's left 5, so that means I'm going to do, well, here actually I'll write it out like this. So my transform from going from x, y, the transformation will be at x minus 5, y plus 1. So for this point, it's going to be at 2 minus 5, -3 plus 1. So the transformed point is going to be at -3 and -2. So now this one is giving you a graph, and it wants you to find what the equation is. So if the original equation was that y is equal to fx is equal, function of x is equal to absolute value of x, so we want to see, okay, what transformations did we do here? So if I take a look, this graph has shifted from here to here. So it's gone right 4, and it's gone up 1, 2, 3, 4, 5, 6. So that means my h is equal to 4 and my k is equal to 6. So if I put it into my function here, I'm going to have y minus 6 is equal to the absolute value of x minus 4. Okay, the next one. So my original has gone, if I take a look at my points, so if I start at this point here, my a to my a prime, I have gone over 1, 2, 3, 4, 5, 6, 7, 8. So I've gone left 8, and then they've gone up. It's gone up 1, 2, 3. So left 8 means that I am going, or my h is equal to 8. Sorry, -8 because it's left. And my k is going up, so it's equal to a +3. So if I substitute it into, my original function would have been y is equal to f of x, so we're not sure what all the other things would have been in there to give us that, but in general it's y is equal to fx. If I substitute in then to y minus k is equal to f of x minus h, I'll have y minus 3 is equal to f of x minus a -8, so this becomes +8. Okay, so just the key ideas, and I usually throw these in here just as a quick review or wrap up. So vertical translation, if x is greater than 0, then you're going to go up. If x is less than 0, then you're going to go down. And when you're doing the mapping or you're trying to do the coordinate or the calculation of the new coordinates, the k is added or subtracted to the y value. If you're looking for horizontal translation, if h is greater than 0, so a positive value, you're going to go up. If it's less than 0, you're going to go, right. And if it's negative, you're going to go left. Okay, your assignment should be in your notes package. I don't see that I put it in here, and we'll work on that in class tomorrow.